Well, welcome back to some more videotaped examples. This time, however, we're working on some truth trees. Again, I think it's helpful for you to see what's going on with the truth trees so you can see that they're not as complicated as it looks when you just read about it in the book. I have here an already symbolized argument that I'm going to construct a truth tree for. Let me explain in this first video how it is that you go about setting this up, or what it is, philosophically, what is it that we're doing. Our argument has two premises and a conclusion that is to be derived from those premises. This argument has, the first premise is going to be a conditional statement. It says, if not C, then if A, then C. The second premise is not C. The conclusion that's drawn is not A. What we want to know in testing for validity is, we want to know if it's possible for these two premises to be true at the same time that the conclusion is false. That's what we're looking for. The way we're going to do that is we're going to use the concept of consistency to test for that. In other words, validity is the concept of, validity says that it's impossible to have all true premises and a false conclusion. Consistency says it is possible for all of these statements to be true at the same time. What I'm going to do is I'm going to turn this argument into a set of statements to be tested for consistency. I'm going to list the assertion of the premises. That means I'm just going to list the premises as true. I've now listed that first premise as true, and I'm going to list the second premise as true. But I'm going to list the denial of the conclusion. So the denial of the conclusion would be not A. What have I done here? By listing these two premises directly, I'm asserting that they're true. And then by listing the denial of the conclusion, I'm asserting that the conclusion is false. So I want to see if the assertion of the premises as true and the denial of the conclusion, if those statements can all be true at the same time. If these can be true, if the assertion of the premises and the denial of the conclusion can be true at the same time, then that means this is an invalid argument, because it is possible for the premises to be true when the conclusion is false. So what I'm going to do now is I'm going to look at the rules of operation that you found in your lecture and that you've read in the textbook. And all I'm going to do as I work down the truth tree is I translate under what conditions would this statement be true. And then I rewrite that down below. So here I've got tilde tilde A. Under what conditions would it is not the case that A be true? Well, we know that the double negation rules itself out. So not A will be true when A is true. Remember what the tilde does to the truth value of the simple statement. If A is true, then tilde A is false and tilde tilde A is true. So not A is the same as A. Now I have to ask the question, under what conditions would this conditional statement be true? Well, you already know that the rule for the conditional statement is that a conditional statement is only false when the antecedent is true and the consequent is false. So under what conditions would this statement be true? Well, this statement would be true when either, notice either is going to cause my tree to branch now, when either the antecedent is false, not C, or the consequent is true. So I just list it there directly. Now, under what conditions, I can check that off, I've completed that one. Under what conditions will not C be true? Well, just as with here, not C will be true when C is true. But notice now, and this is where you close the branches, I have here asserted as true the simple statement C, and if I trace that branch up, I notice that I have also asserted here the simple statement is asserted to be false. So I have both C and not C asserted at the same time. That would be like the statement Johnny is wearing a black shirt and Johnny is not wearing a black shirt are true at the same time, but they're contradictory statements. As such, this branch closes. I do nothing further with that branch. Now over here, I need to ask myself, under what conditions will this conditional statement be true? Well, a conditional statement is only false when the antecedent is true and the consequent is false. So this statement will be true either when the antecedent is false or when the consequent is true. I've now unpacked that one to its bare truth conditions. Notice here now when I trace this up, I have not A asserted as true. When just 2 lines above it, I have A asserted as true. That's a direct contradiction, so that tree closes. Here I have C as asserted as true, and not C asserted as true, so that tree closes. So what this says is, no matter how I try to make these 2 premises and the denial of the conclusion true at the same time, no matter how I turn, I end up with a contradiction in each and every spot. As such, it is not possible for the premises to be true when the conclusion is false. That means that this argument is valid.